group test rewrite. I assume I'm not in class, or I might even be in class showing the video, but here is the rewrite that goes with the test. All right, I'm at tennis or I'm at the math conference, one or the other. Remember on the rewrite, the rule is if I write, you write. So everything I do on the board should be on your papers. If I do a construction, you should be sketching the construction and then doing the work or whatever. But it doesn't be perfect if it's construction, all right? So let's get started so that this doesn't go too super long, all right? Let's go ahead and go with problem 1 here. All right, I've got it drawn on the board behind me, so there's the picture that goes with it. And it said construct, again in big bold print on the paper, the perpendicular bisector of segment AC. And we're going to use one of the rhombus constructions, label the intersection point M, and label the top arc intersection point B. You know, we did a bunch of these in class earlier in the week. I would hope that you all remember how to do this, okay? Again, we're going to do the basic rhombus construction. We don't need to do the whole rhombus here, all right? And so here we go. Remember, we take this pointy end, we make sure this goes a little past halfway. All right, so I'm going to go over here to A. I'm going to take it out to here. I'm going to lock it down. All right, a little bit bigger than halfway. Go there, and then simply draw the arc. All right, so there's my arc, all right, from A. Keeping that very same radius, all right, so the radius stays the same. I'm going to come over to point C, draw the arc, and I've now got basically done, all right, except for drawing a line, all right? So now I'm going to go ahead and draw the perpendicular bisector, okay? And again, we know why this works because it's making a rhombus. Again, this point up here is part of the rhombus, all right? And so let's go ahead now and draw a line that connects them together. All right, these 2 points, all right? And this, what did it say? It said this was point M, right? Okay, and we're going to call the top arc point B, okay? All right, so I believe that just accomplished task 1A, right? Let me see if I got everything here. These are the rhombus constructions, label the intersection point M, label the top point B. All right, and that is done. 1B, all right, given that the length of AB is 16, I don't have AB drawn. Okay, so let's come over and draw AB. All right, so say the measure of segment AB. Let's get it drawn. All righty, and let's draw BC as long as I'm at it. And we'll just draw the top part of the rhombus, and there we go. Okay. Alrighty. So now I can go ahead and finish this. What else does it say? The measure of segment AB is 16 units. All right. So that guy is 16 units. And it also says, what does it say here? Measure of MB. So MB is this segment here. All right, is 4 units. Okay. And what it wants to know is, it wants to know what is the measure. Exact measure, okay, so the word exact is there, all right, of this segment, of segment MC, all right, over here, all right. Well, I'm hoping you all realize, I have more color so that may make it easier here. I'm hoping you all realize that this is indeed a perpendicular bisector. What that means is, the perpendicular part is, it's going to make that right angle. You had some problems like this in the homework that had this thing going on. It's also a bisector, so that means that this segment and this segment have to be congruent to each other. Okay? All right, well, with that going on, what I know is I basically have right here, I simply have this, right? Don't I have this right triangle, where this side is 4 and this side is 16. So if I use Pythagorean theorem, if we go a squared plus b squared equals c squared, well, I know I'm going to have 4 squared plus b squared equals 16 squared. Alrighty, 16 squared. What is it again? I don't have it written down. Oh well. I actually got the whole answer on mine. Where's my phone? I'll do it on my phone quickly.
32.
Okay.
32.
No, that's 16 times 2.
Oh, yeah.
Alrighty. Where's my cool calculator? Okay, 16 times 16. All right. Oh, clear that guy. 16 times 16. 256. Okay. All right, so what I get here is 16 plus b squared equals 256. All right, or b squared is equal to 240. So I know that the measure of b is going to be the square root, right, of 240 units. That guy's basically done. You now have this length right here. Well, and since they're congruent, all right, we know that this should be the answer. So the measure of segment MC is equal to square root of 240 units. All right? Explain your reasoning that goes with your answer to 1B. All right? Well, what do we do? I would say the first thing I would want to say is that because it's a perp bisector, okay, it makes right triangles. Good with that? Okay, so again, the perpendicular bisector part of this makes us a right triangle. And so I can use the Pythagorean theorem to find the missing side. I would say if you had this, it's probably not too bad. You probably should include something about the bisector part as well, talking about these two parts being congruent, which is why you can jump from one triangle over to a triangle. If I'm not mistaken, the last thing it says is this, for bonus points, if you want the bonus points, all right, can you give me the exact answer in simplified form, okay? So could I come over here and take my 240 and then go divided by 2, which would give me 120, divided by 2, which gives me 60, divided by 2 gives me 30, divided by 2 gives me 15, divided by 3, and I get 5 left over. All right, so I look at the numbers here. I have two pairs right here. I have a pair of 2's there, a pair of 2's there. Okay, so what that means is the other answer would be 4 on the outside, and then the 2 and 3 and the 5, okay, root 15 units. That these two here are the exact same thing. And then there's the simplified version of the root. All right, are we good? Are we in the screen still?
Mm-hmm.
Okay.
I actually had the other answer in decimals.
All right. All right, again, remember, exact means the root's going to stay on. Again, I do not want to see that, whatever the answer was, root 14 or 14, whatever it was, something like that. So, all right? Or 15 point something or other.
4-9.
All righty. 2A. Let's go to 2A over here. My phone back out of the way, so I'm going to get behind me. All right, problem number 2. Okay. By the way, is everybody in the video, or is it me or somebody else? You want to stop the video on that last one for a second so people can copy down what's up there. All right, feel free to have them do that. All right, what I have on the board right now is 2A. Basically, it says graph the lines. It says AB goes to the point -4, 0. All right, and 1, 3. All right, CD goes to the points -4, 2. All right, and the point 1, 3, or 1, sorry, 1, 5 up here. And it does say the point E out here is located, all right, at 6, 6. Okay? It then says to reflect line AB. So we're going to reflect line, all right, AB, all right, across the y-axis. Remember, we always move our shapes and do our transformations point by point. So I'm going to move A first. All right, so here's the y-axis. So if A is down here at -4, 0, A prime is going to be over here at 4, 0. Okay? B prime, again, straight across the axis, was at 1, 3, so it's going to be over here, all right, at B prime will be over here at -1, 3. And if I want to go crazy, I suppose I could find the point 6, 6 over here at -6, all right, and +6 up here, all right, and that would be my third point if I wanted to have point E prime. All right, so E prime is over here at -6, 6. I've moved it across the axis, like I said, point by point. And let me come stand in your way for a moment and draw myself my line. Alrighty, and there we go. I do hope I gave you the warning on this test as we worked on it. There's going to be a long test. All right, so be aware of that. All right, yeah. So I reflected across. It says this: point P is the intersection of AB and A prime B prime. Alrighty, so this guy, A prime B prime, is right here. So there's point P. And then it says point Q is at the intersection of CD and A prime B prime. So this guy up here then is point Q. Alright, so that's 2B. 2C says the measure of angle EPA prime. So let's find EPA prime. All right, so EPA prime is down here. So the measure of this angle is 43 degrees. Okay? And then what it wants to do is find the measure, if you can please, of measure of angle E prime QD. So E prime is up here, Q is down here, and D is over here. So it wants the measure here. The first thing I'm hoping you're seeing is the obvious part of this, right? Okay, the obvious part of this is the acute angle over here. Okay, the obtuse angle's up here. There's nothing that connects them together. We have none of our cool, parallel line stuff that connects them. All right, but we do have a measure here. We know that one's acute and one's obtuse. So I'm hoping at minimum that you all see that it's going to be this. Okay, 180 minus 43. All right. So I'm hoping we can all say that the measure of angle E prime QD is equal to 137 degrees. Okay, so I'm hoping you see that part of it at least straightforward. All right. How did you get the answer to 2C? So how did you get this answer? Remember I said that these are worth 3 points each, not just 2 points each, so justifications. All right. The way I got there, all right, is I said, okay, that, let me see what I say, angle EP A prime, all right, is a linear pair, okay, with angle, what is this guy up here? Let's call it QPE. So I said that these two angles right here form a linear pair. Okay? So the measure of angle QPE is 137 by linear pair postulate. Okay? All right, and angle QPE, let's do symbology here, all right, is congruent to angle EQD, E prime QD by corresponding angle postulate. So what I did is I used linear pair from here to here, and then I went from here straight up to here to corresponding angles. Again, could I have done vertical angle? That wouldn't have worked. I could have done linear pair this way and done AEA to get up here. That would have worked. Okay. I could have done a corresponding angle from there to there, and then linear pair in that order. So whatever you did, like I said, just make sure that when you do it, that you reference the angles you're talking about. All right, so we know what the answer is. All righty. All righty. Number 2 is done. I know I have number 3 here somewhere. Here it is. Alrighty, on your screen, here comes the board, it'll come to you. Alrighty, so there we go. Am I close to the middle there? Is that about right? Okay. Alrighty, so here is, alright, number 3. Number 3 is nothing, no argument here. It says, given that these two lines are parallel, that the measure of angle 1 is 68 degrees and that ABC is a right triangle, simply find the measure of angle 2. That's all you had to do. So nothing extra on this problem at all. What I would do first and foremost, label. So if I know the lines are parallel, label the lines as parallel. Okay? Want to go this way better? Okay. If I know the angle 1 is 68 degrees, then label it as 68 degrees. And if I know I have a right triangle, and I know where the right angle is, put the right angle here. Okay? All right, let me show you 2 ways to get there. Okay, let me show you 2 ways to get there. Change colors for each of them. All right. Okay, here's the first way. This is the way I did it, my first time. Okay. I went ahead and I said that this angle down here was 68 degrees. I know that because these are AIAs. Okay, so alternate interior angles with parallel lines makes that 68. Okay. I then went ahead, all right, where's my math here? Okay. I then went ahead and did this. Okay, I did 180 minus 68 plus 90. All right, so what I did was I added these two together, all right, and then took it away from 180 and found that this angle down here was 22 degrees. That's the triangle sum theorem. So that's the triangle sum theorem. And then once I had the triangle sum theorem there, all I had to do from there was do linear pair postulate from here. So all I had to do from here was 180 minus 22. Okay. And what does that give me? Yeah, minus 22 is 160, 158, is that right? All right, so the measure of angle 2 should be equal to 158. Okay. I think probably the shorter way, if you happen to see it, if you saw it, that's great. Okay. The shorter way, I would have done this. Well, what happens if I add those two angles together? Okay, if I add 68 plus 90 together. All right, well, you get, shockingly, 158. Notice that this does form an alternate interior angle with this angle down here. And so another way to get there would be simply do the 1 calculation and call it 158 that way, straight by AIA, and a little bit of angle addition postulate over here. All right? That guy's all done. Okay, that guy is all done. All right. Moving to number 4.
Under board 2.
Woo! All right, let's bring number 4 over here. Oh my gosh, look, it's number 1 again. Okay.
Move 3 out.
Where am I good?
Move 3 out.
Move 3 out? I like 3 right here.
Yeah, I know.
That's good, okay. Alrighty. So it says find x and y, and then it has to justify your math on this. Well, let's justify it as we go. How's that as a plan? Okay. Please tell me, please tell me that we've spent enough time on this that you were all able to go 6x minus 6, all right, equals 4x plus 30. That you were able to take these two and add them together, or make them equal to each other, because these are indeed what? These are vertical angles. So by vertical angle theorem, we know that they are congruent to each other. Okay, so we can now solve this. Let's go 2x equals 36. So I'm going to say x equals 18. Oh, look, I've got my first answer, x equals 18. Okay? All right, the next part I thought would cause you a little bit of grief. Look at this, is weird. So how are you going to find this guy right here? All right? We might justify it out of the way right now. It's not helping me where it's located. All right? Well, I know that x is 18. So could I do this? Could I go 5 times 18 minus 2y? How about plus 6x? Ooh. What is, let me just do this right up front. So what is this 6 times 18 minus 6? Okay. So what's the actual measure of that angle? All right, so I already know what the x is.
102.
So I got 2. So the measure of this angle down here is 102 degrees. So instead of putting the whole equation in, why don't I just put 102 right here? Okay? I know when I add these up, what should happen? They should equal 180, because if I look at these, aren't these same side interiors? Okay, so those two guys are same side interiors. What is 5 times 18? Is that 90? So 90 minus 2y plus 102 equals 180. So negative 2y plus 192 equals 180. Negative 2y equals negative 12. Adding or subtracting negative 192 over. Going out on a limb here, y equals 6. Okay, so there's your two answers. Circled both of them like Mr. Bernard asked me to. So x equals 18, y equals 6. What's my justification for this? Well, I solved for x because by vertical angle theorem, they're congruent to each other. And then I went ahead and did some substitution where I put the 18 back in for the x, and I found out what it was, and did some same side interiors, which made them supplementary over here to solve for the other angle, so y equals 6. All right. Oh my gosh, didn't want to get this last one. So the last one's a proof. Last one's a proof. This is, yeah. This is not as happy a proof as it looks. This is actually a pretty good group test proof. All right. So let me see. 1, 2, 3, 4, 5, 6, 7. I got 9 steps on mine. All right, so let's go here. Let's get the proof started. We all hopefully know how we start the proof. We have our statements. And we have our reasons over here. Triangle, here we go. WXY is equiangular, which I defined for you on the test as saying all the angles are equal. And I'm also going to tell you that the measure of angle 4 equals 60 degrees. These are these squiggly guys, all right, and that will be our given. All right. We're trying to prove that the lines are parallel, okay? So our proof, okay, we're trying to prove, all right, that A is parallel to B. So we're trying to prove that A is parallel to B. So I know I'm going to be one of my converses, okay? I know I'm going to be one of my converses, one of these guys over here. You're fine, I'm going to bring it to you, okay? I know, we'll go that way. Let's go that way. Let's go that way. All right, so again, I know what I'm going to need. I'm going to need a converse of one of these guys. Okay, here's the regular conditionals, corresponding angles, alternate interior angles, AEAs, same side interiors. I'm going to need one of these, all right, on this proof, okay, to bring it together. Okay. Now, when I label my proof, all right, there was an angle 4 down here I forgot about, by the way. All right. When I label my proof with the information I was given, all right, well, what I know is that these angles are all congruent to each other, and I know that this angle down here is 60 degrees. Right away, my brain is telling me, if you look at angle 4, look at angle 3, okay? Right away, I can see that 4 and 3 are going to be AIAs. So if I can prove that angle 3 and 4 are congruent to each other, I've got the lines parallel by AIA converse. So that's going to be my task. Can I prove the angles are congruent to each other? All right? So here we go. Let's prove it. Well, what does equiangular mean? Okay, it means all the angles are equal to each other. So let's do that. So measure of angle 1, oh, my mistake, is equal to the measure of angle 2, is equal to the measure of angle 3, and that's what I just said. Definition of equiangular. Okay, so by definition of equiangular, I know that 3 angles are going to be congruent, all right, to each other. I also know this, by the way, don't I? Don't I know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3? Well, if I add those 3 angles up, what do they equal to? Don't they equal 180? It's a triangle, correct? So don't they equal 180 degrees? The reason for that, to remember, is the triangle sum theorem. Check your note cards. Triangle sum theorem again says the angles add up to 180 degrees. All right, here's the tricky part. This is what's going to look weird to you. Are you ready? I am going to combine those 2 steps. Now remember, the angle I want is angle 3, correct? All right, so I'm going to work with angle 3. Here we go. Okay, the measure of angle 3 plus the measure of angle 3 plus the measure of angle 3 equals 180. What did I do? Okay, what did I do? Well, what I did is in this statement right here, since I know they're all equal to each other, I simply substituted an angle 3 in for the first 2 positions. Okay? So if I substituted, that's substitution. Okay? So let's add the left side. If you add the left side, what do you get? Well, you've got 3 angle 3s. So let's add them up. What do you get? You get 3 times the measure of angle 3 equals 180. You should know what that guy is. That's just simplifying, right? Okay, so I simplified. All right? Well, what would happen if I divided both sides by 3? Wouldn't I get this, that the measure of angle 3 is equal to 60 degrees? Okay? And so that would be by division property of equality. So now I've got this guy over here at 60 also. Well, let's change colors so you can see this guy again quickly. All right, if this is true, don't I have two things that are equal to the same thing? Aren't they both equal to 60? If they are both equal to 60, doesn't that mean that the measure of angle 3 must be equal to the measure of angle 4? All right, and that's going to be true by transitive property. And that's transitive property, remember, of equality, because we have equals here. Remember, that sign and that sign have to be in agreement the same way. When I did division property, it had to be the equals here. Same idea. Okay? Be nice if we were done, except the problem is, if you remember what the theorem said, all right, the angles have to be congruent to each other. Well, right now they're not congruent to each other. Right now they are equal to each other. So I get to do this fun little next step, which is now to say that angle 3 is now going to become congruent to angle 4. The reason for that is the definition. Just go def of congruence. The definition of congruence, by the way, is this hinged door that allows you to go back and forth between congruence and equality. All right, so I'm going from equality to congruence here, so I can go either way with this. Either time it's going to be definition of congruence. Well, now that I have angle 3 congruent to angle 4, so now that I know that these two angles are congruent to each other, now why don't I simply say that A is parallel to B by not AIA, but we're proving parallel lines, so AIA converse. Okay, AIA converse, because we're proving parallel lines. Is it 9 steps? 1, 2, 3, 4, 5. Yep, 9 steps. All right, same as on my paper. Okay. Alrighty, so guys, there it is. All right, there is the entire group test for you. All right, hope it helps. Like I said, I may be in class for some of you, I may not for others. Heck if I know what's going on. But your test should be a couple days from now. The next day in class, we'll do our Kahoot review. All right, remember, this thing that you just did should be completely done. It's a homework assignment, so that's due tomorrow, next day of class or Friday for you guys. All right, and I will see you.